Hey everyone, Kevin here, back with another AIME question. So this time we're looking at the 2002 AIME 2 problem 10. Once again, if you need to open this up on a new tab, feel free to do so, and let's get started. So while finding the sine of a certain angle, an absent-minded professor failed to notice that his calculator was not in the correct angular mode. And I think we've all seen this happen in our lives, where our calculator is in either degrees or radians, and we think it's the other way around, and we end up getting a question wrong, be it on like a test or the SAT or something else. Okay, so the two least positive real values of x for which the sine of x degrees is the same as the sine of x radians. Okay. So we have the sine of x degrees is equal to sine of x radians. And these answer formats are a bit weird, but it's okay. Where m and pq are positive integers, and this is pretty important because it's our answer format. And like all AIME questions, we want their sum. So of course we can't really do anything if we have degrees and radians. We have to convert one into the other. So we either convert degrees into radians or radians into degrees. Though because I'm a proper mathematician, I decide to convert degrees into radians because mathematicians like radians a lot. Maybe because it's a bit more complicated and involves like pi, which it seems more natural, I guess. So we begin the conversion. So x degrees over 360 is some x prime radians, and this is 2 pi. So if we want to convert this into radians, then x prime equal to pi x over 180. And this is just converting our degrees into radians. Our equation will then be sine of pi x, let's just use pi x, sine of pi x over 180 is equal to sine of x, right? Okay. And this is a situation where we have sine A is equal to sine B, and we want to find the relations between A and B. In which case, and you should already know this, we either have so pi x over 180 minus x is an integer multiple of 2 pi, so 2a pi. This is because the sine function is periodic with period 2 pi. Or we have that plus x is equal to 2a plus 1 pi. And this is because we have the theorem that sine of theta is sine of pi minus theta. So we get these two formulas and we can solve for x. In the first case, x is equal to 2a pi over, let's bring the 180 up here. So this is pi minus 180. And in the second case, x is, we're once again bring the 180 up. And this is pi plus 180. So we have these two families of solutions for integer a. Got to put that. And we want the smallest solutions. So let's just see what the smallest positive real solutions to these are. In the first case, we see that the denominator will always be negative. So we want to choose a to be negative. And a equals -1 will give us the smallest value. And a equals -2 will give the next smallest, and so on. And for the second case, the denominator is positive, so we have that the smallest, okay, so if a is like -1, then the denominator will be negative. So we can start at equals 0, and then a equals 1 will be the next biggest one. So let's do that. And since we want the first two smallest positive real values, let's just compute the first two values of each family, in which, so we're basically ensured that our two values lie in those four. So in the first case, a equals 1 gives, or sorry, a equals -1 gives 360 pi over 180 minus pi. And a equals -2 gives 720 pi over 180 minus pi. In the second case, x equals 1 gives, or sorry, we're starting from x equals 0. I confused myself. So that gives us 180 pi over pi plus 180, and x equals 1 gives 540 pi over pi plus 180. So we're guaranteed that our two values lie in these four, because these are our only two families of solutions, and these four are our two smallest values from each family. So let's do a bit comparing. So we either have that it's the first or the smallest one from each family, or that it's the smallest two from one family. So let's compare the a equals to -1 case from the first case and the x equals 1 from the second case. So let's compare 360 pi over 180 minus pi to, let's just use this symbol. Cross multiply, we get pi this is 540 pi, 180 minus pi, and simplifying, 360 plus 540 is going to be 900 pi squared on the left side, and some pretty huge number on the other side. So I said big. So it would be 540 times 180 plus 360 times 180, so 180 times 900 pi. And when we cancel out a pi, obviously the right side is larger, So that means the left side is smaller and the a equals the -1 case is smaller. Okay. And for the other two, we can just compare the numerators and denominators. So 720 pi and 540 pi, well, a equals -2 is bigger, and 180 minus pi plus 180, well, 180 minus pi is smaller. So a bigger numerator and a smaller denominator makes for a bigger quotient, and thus a equals -2 will be greater than the a equals, okay, this is supposed to be a. Okay, a equals -2 case is greater than the a equals 1 case. So therefore, or the a equals 0 case, sorry. I was comparing the wrong values too. It's 720 pi to, okay, that's even bigger. That's even bigger difference. So our solutions are the smallest value in each family. And thus, it is, well, I think it's just 360 plus 180 plus 180 plus 180, which is 540 plus 360, which is 900. And that should be the answer.